On the night of August 15th, 1977, a radio telescope in Ohio recorded something it had never recorded before and has never recorded since. Welcome to the Sleepy Lab. Tonight, we drift through one of the quietest mysteries in science. A signal that lasted 72 seconds, was never heard again, and has never been fully explained. If you find these nights restful, consider subscribing, one sleepy soul at a time. Now, let's begin. Somewhere in Ohio, in the late summer of 1977, a machine was listening to the sky. It had been listening for years. Every day, quietly, patiently, recording the faint radio whispers of the cosmos onto long rolls of paper printout, column after column of numbers and letters, most of them unremarkable. The machine was called Big Ear. It belonged to Ohio State University, and it was not what most people picture when they think of a radio telescope. There was no great dish turning slowly against the sky. Big Ear was something simpler, and in its simplicity, something almost meditative. A flat ground plane reflector spread across the earth like a still pond, roughly the size of 3 football fields laid end to end. It did not move. That was the essential thing about Big Ear. It was what astronomers call a transit telescope. It did not steer toward targets, did not track objects across the sky. It simply waited, held perfectly still, while the earth turned beneath it and the sky drifted slowly overhead. Each day, a different strip of the heavens would pass through its field of view. Each night, the same slow rotation, the telescope receiving whatever the universe chose to offer. There is something quietly profound about that. A machine that does not reach out, but only listens, trusting that if something is there, it will come. Big Ear had 2 feed horns. Each one sampled a slightly different strip of sky, not simultaneously, but separated by about 2 minutes of time. As the Earth turned, a signal from a fixed point in space would pass through the first horn, then, roughly 2 minutes later, through the second. This 2-horn design was not incidental. It was a safeguard, a kind of double check built into the instrument itself. If something appeared in both horns, separated by that expected 2-minute interval, it was more likely to be real, a genuine signal from a fixed point in the sky. If something appeared in only one horn and not the other, that was harder to explain. On the night of August 15th, 1977, at 11:16 in the evening, Eastern Time, something appeared in the first horn. It did not appear in the second, not 2 minutes later, not at all. The telescope recorded it faithfully as it recorded everything, not as sound, not as light, but as a column of alphanumeric characters printed onto paper. Each character represented a level of signal intensity, low signals printed as single digits, stronger signals as letters, moving up through the alphabet as the intensity rose. Most columns looked like this, 1s and 2s, the quiet static of the background universe. This column looked different. The characters rose, 6, E, Q, U, then fell again, J, 5, a smooth arc of intensity, climbing and descending in the space of 72 seconds. The peak of that arc, the letter U, corresponded to a signal roughly 30 times stronger than the surrounding noise. The printout sat in a stack of other printouts. Days passed. Then a volunteer researcher named Jerry Amon sat down to review the data. He was not a staff astronomer. He gave his time to the project because he believed in what it was trying to do. He moved through the columns methodically, the way you move through something when you expect to find nothing unusual. And then he found it. He read the sequence. He read it again. He reached for a red ballpoint pen, drew a circle around those 6 characters, and in the margin beside them, he wrote a single word. Wow. That word, written in ordinary red ink, on an ordinary sheet of paper, by a man sitting quietly at a desk, became the name by which this signal would be known for the rest of recorded history. The WOW signal. It was never given a formal scientific designation. It carries only the weight of that one handwritten word, and somehow that feels right. Something that has resisted every explanation for nearly 5 decades perhaps deserves a name that is more feeling than formula. Now, what made it so unusual? The signal was centered very close to 1420.405 MHz, a frequency that carries a particular significance in the universe. At that frequency, neutral hydrogen emits a faint, natural radio wave. Hydrogen is the most abundant element in the cosmos. 100 billion galaxies, each containing hundreds of billions of stars, and the space between them threaded with clouds of hydrogen, all quietly humming at that same frequency. In 1959, 2 physicists, Philip Morrison and Giuseppe Cocconi, published a paper suggesting that if any civilization wanted to send a signal across interstellar space, the hydrogen frequency would be the logical choice, a universal landmark, a frequency that any species capable of radio astronomy would already know. The idea was simple and elegant. If you want to leave a message where someone might find it, you leave it somewhere they are already looking. The WOW signal was sitting almost exactly there. And its shape was unusual too. The way it rose and fell, that smooth, symmetrical arc, matched precisely what astronomers would expect from a fixed point source drifting through the telescope's beam as the Earth rotated. It is called a Gaussian profile, and it is a signature, a quiet but meaningful one. Natural radio interference tends to be erratic. It spikes and stutters. It bleeds across frequencies. It appears in both feed horns at once because it is close, a satellite overhead, a piece of electronics nearby, a reflection from an aircraft. The WOW signal did none of those things. It appeared in one horn only. It was narrow, far narrower than most natural astrophysical sources, which tend to broadcast across broad swaths of the radio spectrum. It was strong. It was shaped correctly. It came from the direction of the constellation Sagittarius, roughly toward the dense, star-filled center of our own galaxy. And then it was gone. The second feed horn waited its 2 minutes and heard nothing. That silence, that absence in the second horn, is one of the details that has stayed with researchers ever since, because it means one of 2 things. Either the signal ended before the second horn could receive it, or it was never there to begin with, which the first horn's data makes very difficult to believe. 72 seconds. That is all Big Ear ever heard of it, and in the decades that followed, no matter how many times astronomers pointed instruments at that same patch of sky, no matter how sensitive those instruments became, the signal did not return. But we are getting ahead of ourselves. For now, let the image settle quietly. A flat field of metal and wire, spread across the Ohio Earth beneath a late summer sky. The stars of Sagittarius drifting slowly overhead. A machine that does not reach, only listens. And for 72 seconds, something answered. No one was watching when it happened. The Big Ear telescope did not send alerts. It did not ring a bell or flash a light. It simply recorded, the way it always did, converting the faint whisper of the sky into numbers, printing them onto long rolls of paper, one column at a time. The night of August 15th passed like any other night at the observatory. The telescope held its position, as it always did, and let the sky move through it. The signal came, rose, peaked, and faded. The paper kept moving. The printer kept printing. And no one in the building knew that anything unusual had occurred. That is one of the quieter details of this story. The wow signal was not witnessed, it was discovered. Days passed between the moment the signal arrived and the moment any human being understood what the data contained. The printout sat among other printouts, unremarkable from the outside, waiting. Jerry Amon was a volunteer. That word is worth holding for a moment. Not a senior faculty member, not a funded researcher with a dedicated office, a volunteer, giving his time to a survey that most of the scientific world considered a long shot at best. He had been helping with the Big Ear SETI project, reviewing the data that the telescope produced, looking for anything that did not belong. It was painstaking work. The telescope generated a great deal of output, most of it the ordinary static of the cosmos, background noise, known sources, the unremarkable hum of a universe going about its business. Amon would have moved through page after page of that output, column after column of numbers and letters, most of them low, most of them flat. And then he reached a sequence that was not flat. The data from Big Ear was printed in a particular format. Each signal intensity level was represented by a single character, a number, or a letter. The numbers ran from 1 to 9, representing the lower intensities. When the signal grew stronger than a 9 could express, the system moved into letters. A represented 10, B represented 11, and so on upward. Most of what Amon would have seen, scanning those columns, were 1s and 2s, occasional 3s, the quiet arithmetic of an empty sky. What he found instead was this: 6, E, Q, U, G, 5. 5. 6 characters, each one a step in a story the telescope had recorded without knowing it was recording anything at all. The 6 was already unusual. A signal intensity of 6 in a survey that typically showed 1s and 2s would have been worth a second look on its own, but the sequence did not stop at 6. It climbed. E, which meant 14, then Q, which meant 26, then U. U meant 30 times the background noise level, in a single narrow channel, rising smoothly, the way a distant point source rises as it drifts into the center of a telescope's beam, and then falling again, just as smoothly. J, then 5, the signal descending back into the ordinary noise of the sky as whatever had produced it drifted, or ended, or simply ceased. The shape of that sequence is important. It was not a spike. It was not a sudden burst of interference that appeared and vanished in a single sample. It was a curve, a smooth, symmetrical arc of intensity that rose and fell across 6 data points, tracing exactly the profile you would expect from a fixed point source moving through the telescope's field of view as the Earth rotated. That shape has a name in radio astronomy. It is called a Gaussian profile, and it is one of the signatures that distinguishes a genuine distant source from something local and artificial, a passing aircraft, a stray transmission, a piece of equipment misbehaving nearby. Local interference tends to be irregular. It tends to appear and disappear without the smooth geometry of something genuinely far away. The wow signal had that geometry. Amon looked at the sequence. He looked at it again. He reached for a red ballpoint pen. He drew a circle around the 6 characters, and in the margin beside them, in ordinary handwriting, he wrote a single word: wow. Not a formal designation, not a scientific label, just the honest, unguarded response of a person who had been looking at flat data for a long time and had suddenly found something that was not flat. A word that carried no claim about what the signal was or where it came from. Only the recognition that something here was different. That handwritten annotation is the reason we call it what we call it today, the wow signal. Named not in a journal, not in a press release, but in the margin of a paper printout in red ink by a volunteer who was simply paying attention. The original printout still exists. It has been displayed publicly. That small circle, that single word in the margin. They have become, in their quiet way, one of the more remarkable artifacts in the history of astronomy. Not because they prove anything, but because they mark the moment a human being first recognized that something unusual had passed through a machine in a field in Ohio on a night when no one was watching. Eamon brought the printout to the attention of the project. The data was examined more carefully. The signal's properties were noted one by one. Its frequency, centered so precisely on the hydrogen line. Its narrow bandwidth, narrower than almost any natural source. Its single-horn detection, which ruled out most forms of local interference. Its Gaussian shape, which pointed towards something genuinely distant. Each property, considered alone, might have had an ordinary explanation. Together, they did not. And yet, the signal itself offered nothing more. No structure within the 6 characters that suggested a message. No modulation, no pattern. No second transmission to confirm the first. Just those 6 alphanumeric steps, a rise and a fall, printed on paper by a machine that had no way of knowing what it had recorded. There was something almost meditative about that. The universe, if it was the universe, did not announce itself. It did not repeat itself. It passed through a flat metal field in Ohio, left a curve of numbers on a roll of paper, and moved on, or stopped, or had never intended to be heard at all. We do not know which of those is true. What we know is that Jerry Amon, sitting with a printout and a red pen, found the curve, and that the word he wrote beside it, small, unhurried, entirely human, became the name by which this moment has been known ever since. The sky outside is quiet now. Whatever passed through Big Ear on that August night is still out there, somewhere, in the direction of Sagittarius. Or it is not. Or it was never what it seemed. But the printout remains, the circle remains, and the word in the margin, written in red ink by a volunteer who was simply paying attention, remains. Some things do not need to be explained to be worth remembering. The character at the peak of that curve was the letter U. In the coding system Big Ear used, each alphanumeric character represented a range of signal intensity. A number like 1 or 2 meant the signal was barely above the noise. Letters came after the digits, representing higher and higher levels. U was deep into the letter range. It corresponded to a signal roughly 30 times stronger than the background noise of the sky. 30 times. Not a flicker, not a marginal reading that might dissolve under scrutiny. 30 times the noise floor, rising smoothly, holding near its peak, then falling away again in the same quiet arc. The kind of shape that, in radio astronomy, carries a specific meaning. It means the source was not moving erratically. It was not flickering or pulsing in the way interference tends to. It drifted through the telescope beam the way a distant, fixed point in the sky would drift, steadily, predictably, following the rotation of the Earth. That shape has a name. Astronomers call it a Gaussian profile, and its presence in the WOW data was one of the first things that made the signal difficult to dismiss. But the shape was only part of it. The frequency mattered just as much, perhaps more. The signal was centered very close to 1420.405 MHz. That number, to a radio astronomer, is not arbitrary. It is one of the most recognizable numbers in the study of the cosmos. It is the frequency at which neutral hydrogen naturally emits radio waves. A hydrogen atom, in its lowest energy state, can undergo a tiny internal transition, a flip of the electron's spin relative to the proton, and when it does, it releases a photon at almost exactly that frequency, 1420.405 MHz. Every hydrogen atom in the universe that undergoes that transition produces the same emission, at the same frequency, regardless of where it is. And hydrogen is everywhere. It is the most abundant element in the universe by a considerable margin, the first element to form after the Big Bang, the fuel of stars, the foundation of water, of organic molecules, of life as we understand it. Roughly 3/4 of all ordinary matter in the universe is hydrogen. Clouds of it drift between the stars. It fills the spaces inside galaxies and between them. When radio astronomers scan the sky, the hydrogen line is one of the most persistent signals they encounter, a constant, quiet presence, a kind of background voice the universe never stops speaking. That ubiquity is precisely why two physicists, writing in 1959, suggested it might be the right place to listen. Philip Morrison and Giuseppe Cocconi published a paper that year in the journal Nature. It was a careful, measured argument. They were not claiming that extraterrestrial civilizations existed. They were asking a quieter question. If such civilizations did exist, and if they wanted to be found, what frequency might they choose to transmit on? The answer, Morrison and Cocconi suggested, was almost self-evident. Any civilization capable of building a radio telescope would know the hydrogen line. It required no shared history, no common language, no prior contact. It was written into the physics of the universe itself, a landmark that any sufficiently advanced observer, anywhere, would recognize. They called it a cosmic watering hole, a place in the radio spectrum where, by analogy with the watering holes of the natural world, different kinds of creatures might gather. That paper was published 18 years before the WOW signal arrived. When the signal appeared at almost exactly that frequency, it was not a coincidence that researchers noticed. The hydrogen line was precisely where SETI surveys have been told to look. Big Ear was listening there deliberately, and something, on the night of August 15th, 1977, was transmitting there, or appeared to be. The bandwidth of the signal added another layer of strangeness. Bandwidth, in radio terms, refers to how wide a signal is across the frequency spectrum. A signal with broad bandwidth spreads its energy across many frequencies at once. Most natural radio sources in the universe are broad. Pulsars sweep across wide frequency ranges. Quasars emit across enormous swaths of the spectrum. Even the hydrogen line itself, when observed from natural clouds of interstellar gas, is broadened by the motion of the gas, individual atoms moving toward or away from the observer, each shifting the frequency slightly through the Doppler effect, smearing the line into a wider shape. The WOW signal was not smeared. Its bandwidth was extremely narrow, narrower than almost any natural astrophysical source. Narrower, in fact, than the resolution limit of the Big Ear instrument itself, which meant the true bandwidth might have been even tighter than what the data could show. A signal that narrow concentrates all of its energy into a very small slice of the spectrum. That is not what nature tends to do on its own. It is, however, what a transmitter does. A deliberately engineered radio signal is typically narrow because narrowness is efficient. It puts all the power where you want it, rather than spreading it thin. The narrowness of the WOW signal was not proof of anything. but it was consistent with something artificial in a way that broad natural sources are not. Taken together, these qualities formed a kind of quiet argument. The signal was strong, 30 times the noise floor. It was centered on the one frequency that physicists had identified, nearly 2 decades earlier, as the most logical choice for interstellar communication. Its shape matched what a fixed, distant point source would produce as the Earth rotated, and its bandwidth was narrower than nature typically produces. None of these features, individually, was impossible to explain away, but together, they pointed in a direction that was difficult to ignore and equally difficult to confirm. Morrison and Cocconi, in their 1959 paper, had written something that stayed with the researchers who came after them. They suggested that the probability of success was difficult to estimate, but that if we never searched, the chance of success was zero. There was a patience in that framing, a willingness to look without demanding an answer on any particular schedule. Big Ear had been looking for years before that August night. It would go on looking for years afterward, and the signal, whatever it was, did not come back. But for 72 seconds, something passed through the beam of a flat metal field in Ohio and left a curve of numbers that peaked at the letter U, at a frequency that hydrogen has been broadcasting since the first stars formed, at a bandwidth so narrow it seemed almost deliberate. The universe is old, roughly 13.5 billion years old, as far as we can measure. In that time, hydrogen has been emitting its quiet signal from every corner of space. It was there before the Earth existed. It will be there long after. If someone, somewhere, wanted to be heard and wanted to choose a frequency that any listener would recognize, they would not need to invent anything new. They would only need to listen to what the universe was already saying and transmit beside it, quietly, at 1420.405 megahertz, where the hydrogen sings. And yet the frequency alone was not what made the signal strange. Most radio sources in the sky are broad. They spill their energy across wide swaths of the spectrum the way a fire spills light, in every direction, at every wavelength, all at once. Pulsars sweep their beams across the cosmos, and they are loud. But they are loud across many frequencies simultaneously. Quasars, those brilliant cores of distant galaxies, pour out radio energy in great wide floods. Even the quieter, more ordinary sources, clouds of ionized gas, the remnants of old supernovae, tend to spread themselves thin across the dial. Nature, as a rule, is not precise. What came through the big ear that August night was precise, narrow in a way that natural processes rarely produce. The signal occupied an extremely thin slice of the radio spectrum, far narrower than almost anything the sky routinely offers. That narrowness is not a small detail. It is one of the things that makes the signal difficult to explain away. A narrow signal requires a source with very specific properties, either something extraordinarily cold and still, or something engineered. Natural narrowband emission does exist. The hydrogen line itself is one example, but a source broadcasting at that intensity, that narrowly, from that direction, without any known object to account for it. That combination does not resolve easily into the familiar. And then there was the shape. When a fixed point in the sky drifts through the beam of a transit telescope, it does not arrive all at once and vanish all at once. It enters the edge of the beam gradually, brightens as it moves toward the center, reaches its peak, and then fades again as it drifts out the other side. The resulting curve, if you were to draw it, would be smooth and symmetrical, a gentle hill. Mathematically, it follows what is called a Gaussian profile, the same bell-shaped curve that describes so many natural distributions, from the heights of people to the spread of light through a lens. The WOW signal traced exactly that curve, rising through the numbers on the printout, through 6, through E, through Q, through U at its peak, then falling back through J and 5 and into the noise, smoothly, symmetrically, as though something fixed and distant had drifted through the beam at the pace the sky itself moves. That shape matters. Local interference, a stray transmission from a passing aircraft, a satellite, a piece of malfunctioning equipment, does not usually behave that way. Local sources move differently, or they appear and disappear abruptly, or they fluctuate in ways that don't follow the telescope's geometry. They leave irregular marks, jagged edges. The WOW signal left no jagged edges. It left a curve that matched, almost perfectly, what the telescope's own beam pattern would predict for a source at interstellar distance. There is another test that local interference tends to fail. The Big Ear had 2 feed horns, 2 receivers, each sampling a slightly different strip of sky, separated by about 2 minutes of time as the Earth rotated. If a source of interference was nearby, on the ground, in the atmosphere, in low orbit, it would almost certainly appear in both horns. The 2 horns were close enough together that any local signal would wash over both of them. The WOW signal appeared in 1 horn. Only 1. The second horn passed over the same coordinates roughly 2 minutes later and recorded nothing unusual, just the ordinary background, just the quiet hum of the universe going about its business. That single horn detection is one of the most quietly compelling aspects of the event. It is not proof of anything, but it is consistent with a source that was genuinely fixed in the sky, genuinely distant, genuinely point-like, something that the beam swept across and then left behind, rather than something that was present in the local environment. A nearby source of interference would have had to vanish in the exact 2-minute window between the horns. Possible, in principle, but the combination of factors, the narrow bandwidth, the Gaussian profile, the single horn detection, the frequency, each one individually might be explained. Together, they form a pattern that resists easy dismissal. And the pattern pointed somewhere, toward the south, toward a region of sky that, on a clear night, sits low above the horizon in the northern summer, toward the constellation Sagittarius. Sagittarius is not a dramatic constellation to look at, a modest arrangement of stars, not particularly bright, but it marks something significant. It lies in the direction of the center of the Milky Way. When you look toward Sagittarius, you are looking inward, toward the dense, ancient heart of the galaxy, toward a region where stars are packed far more tightly than they are out here, in the quieter suburbs where our own sun drifts. The galactic center is roughly 26,000 light-years away, a distance so large it becomes almost abstract. But the stars between here and there number in the hundreds of billions. Old stars, many of them. Stars that have had time, far more time than our sun, to warm whatever worlds might circle them. The signal came from that direction, not from a specific star. The resolution of the Big Ear was not fine enough to pinpoint a single source, only a region of sky, a patch of Sagittarius, somewhere in that dense and ancient field. No known natural object in that part of the sky has since been identified as a plausible explanation. Researchers have looked, the coordinates have been examined, revisited, searched with instruments far more sensitive than anything available in 1977. And the sky there looks, to all appearances, ordinary. A scattering of stars, background noise, nothing that announces itself as the origin of what passed through the beam that night. That absence is its own kind of data. It does not confirm anything, but it means the signal remains, after nearly 5 decades, without a clean natural account. The universe is full of radio sources, and most of them, when examined carefully, reveal themselves. They repeat, or they vary in predictable ways, or they match the known signatures of known phenomena. The wow signal has not revealed itself. It came once. It rose through the numbers on a paper printout in a pattern that matched a distant, fixed, narrowband source drifting through a beam pointed toward the center of the galaxy. And then it was gone. The second horn heard nothing. The follow-up observations heard nothing. The weeks and months of repointing the telescope at those coordinates heard nothing. The signal did not repeat, did not vary, did not announce itself again in any form that any instrument has since been able to find. What remains is the shape of it, the narrowness of it, the frequency of it, the direction of it, and the single word written in red ballpoint pen beside a column of alphanumeric characters on a paper printout that has since been preserved behind glass. The universe does not often offer puzzles this clean. Most anomalies, when examined long enough, dissolve into the ordinary. They turn out to be instrument errors, or known phenomena seen at unusual angles, or coincidences that seem significant only briefly. The wow signal has been examined for nearly 50 years and has not dissolved. It sits at the edge of what we can explain, not demanding an interpretation, not offering one, just present in the record. The way a single clear note might linger in a room long after the source of it has gone quiet. Toward Sagittarius, toward the center of everything. Something passed through the beam, and the beam moved on. No known object in that part of the sky has since been identified as a plausible source. Astronomers have looked. They have cross-referenced catalogs of pulsars, of quasars, of radio-bright galaxies and stellar remnants. Nothing in that direction, at that frequency, at anything close to that intensity, has offered itself as an explanation. The sky in the direction of Sagittarius is not empty. It is, in fact, among the most crowded regions visible from Earth, thick with stars and gas, and the slow gravitational pull of the galactic center. And yet, within all of that density, nothing has raised its hand. The silence of the natural world, in that particular patch of sky, is part of what makes the signal so difficult to set aside. Big Ear was not simply scanning the sky out of curiosity. It was part of a deliberate, organized effort, a survey designed specifically to listen for signals that might not be natural. The program was called SETI, the Search for Extraterrestrial Intelligence. Those words carry a weight that is easy to underestimate. For most of human history, the question of whether other minds existed beyond this world was a matter for philosophy, or theology, or private wondering in the dark. SETI made it a scientific program. It gave the question instruments, and frequencies, and funding, and schedules. It said, quietly and without drama, "We do not know the answer, but we can listen, and listening is a reasonable thing to do." The formal beginning of that effort is usually traced to 1960. A young astronomer named Frank Drake pointed a radio telescope in Green Bank, West Virginia, at two nearby, sun-like stars. He called the project Ozma, after a fictional queen of a distant and unreachable land. The name was chosen carefully. It acknowledged, without embarrassment, that the destination might be unreachable, that the search might return nothing. Drake listened for several weeks. He heard nothing that could not be explained. But the act of listening had been performed, seriously, with real equipment, by a credentialed scientist at a recognized institution. That mattered. It meant the question had crossed a threshold. It was no longer only a dream. Drake went on to do something else that has shaped the way scientists think about this problem ever since. He wrote an equation. Not an equation in the sense of a calculation with a clean answer at the end. More like a framework, a way of organizing ignorance. The Drake equation lays out, in sequence, every factor that would need to be true for a communicating civilization to exist somewhere in the galaxy and be detectable by us. It begins with something relatively well understood: the rate at which new stars form in the Milky Way. Astronomers have measured this with reasonable confidence. Roughly a handful of new stars, on average, each year. From there, the equation asks what fraction of those stars have planets. For most of the 20th century, that fraction was unknown. Now, after decades of telescope surveys, we know it is high. Most stars, as far as we can tell, are accompanied by worlds. But then the equation moves into territory where certainty begins to thin. It asks what fraction of those planets are capable of supporting life. And here, the honest answer is that we do not know. We have one example. One planet, this one, where life arose. Whether that makes life common or rare is a question that a single data point cannot answer. The equation continues. Of the planets where life could arise, on how many does it actually arise? And of those, on how many does it eventually develop intelligence? And of those, on how many does that intelligence develop the technology and the inclination to send signals into space? And for how long do those civilizations transmit before they fall silent, or change, or end? Each of these questions is nested inside the previous one. Each carries its own uncertainty. When Drake first presented the equation at a small scientific meeting in 1961, the gathered researchers worked through it together. Their estimates varied enormously. Some thought the galaxy might hold thousands of communicating civilizations. Others thought it might hold very few. The equation did not resolve the disagreement. It was never meant to. What it did was make the disagreement legible. It showed exactly where the uncertainty lived. It gave scientists a shared vocabulary for a question that had previously been too vague to argue about productively. The output of the Drake equation is not a number. It is a range. A wide one. Depending on how you fill in the variables, the answer might be one, meaning us, alone, or it might be millions. Both are consistent with what we currently know. That is not a failure of the equation. It is an honest reflection of how little we have been able to confirm. The universe is roughly 13.5 billion years old. The Milky Way contains something in the range of 100 billion stars. Many of those stars are far older than our Sun. If life arises wherever conditions allow, and if intelligence follows from life with any regularity, then the galaxy has had an enormous amount of time to fill with minds. And yet, we have not heard from them. Or we have heard once, briefly, from the direction of Sagittarius on a warm August night in 1977, and then never again. The Big Ear survey was one small part of this larger effort. A patient, methodical sweep of the sky, frequency by frequency, strip by strip, year after year. The telescope did not choose where to look. It waited. The Earth turned, and the sky moved overhead, and the feed horn sampled whatever passed through the beam. Most of what passed through was noise. The low, constant murmur of the cosmos. Hydrogen clouds drifting between stars. The faint warmth of the cosmic background. The occasional bright pulse of a known source. All of it cataloged, printed, set aside. And then, on a night in August, something different passed through. something that did not fit the catalog. Something narrow and strong and shaped exactly as a distant point source should be shaped. Centered on the frequency that two physicists had suggested nearly 2 decades earlier would be the most logical choice for a signal meant to be found. The telescope recorded it faithfully, the way it recorded everything. Without judgment, without alarm. The paper moved through the printer, the characters appeared, and the night continued. It would be days before anyone read what had been written there. Jerry Amon sat with that printout and saw what the telescope had seen. He reached for a red pen. He drew a circle. He wrote one word. And in doing so, he connected a single moment of detection to a question that Frank Drake had formalized, that Philip Morrison and Giuseppe Cacconi had reasoned toward, that Carl Jansky had unknowingly opened the door to in 1932 when he first heard the radio hiss of the galactic center. A question that goes back much further than any of them. Are we the only ones? The Drake equation does not answer that. No equation can, but it holds the question open in a way that is neither hopeful nor despairing. Just honest. Just careful. Just willing to sit with uncertainty the way the sky sits with silence, patiently, and for as long as it takes. The big ear had been listening for years before that August night. Not weeks, not months. Years of quiet, methodical scanning, the telescope doing what transit telescopes do, waiting for the sky to bring the universe to it, strip by strip, night after night. It had heard a great deal in that time. Pulsars ticking with the regularity of distant clocks, the broad, diffuse warmth of galactic hydrogen spread across the sky like a slow tide. Interference from the ground, from satellites, from the ordinary electromagnetic noise of a civilization that had not yet learned to be quiet. All of it recorded, all of it printed, all of it eventually reviewed by human eyes looking for something that did not belong. And for years, nothing did. That is worth sitting with for a moment. The survey was not new when the WOW signal arrived. The telescope had already accumulated a long, patient history of finding nothing extraordinary, which is, in its own way, a kind of data. Absence is information. Silence is a measurement. Every night that passed without a structured, narrowband signal rising cleanly out of the noise was a night that narrowed the possibilities, or widened them, depending on how you held the question. Then came August 15th, 1977. And then, after that, silence again. Not the ordinary silence of an uneventful night, a different kind of silence. The silence that follows something unexpected, when the people who witnessed it turn back to look and find nothing there. The researchers at Ohio State did not simply note the anomaly and move on. That is not how science works, and it is not what the signal deserved. Within months, they were pointing their attention back at the same coordinates in Sagittarius, waiting to see if whatever had spoken once would speak again. It did not. The first follow-up observations came quickly, then more still, as the months stretched into years and the question refused to resolve itself. In total, more than 50 separate observations were made of that region of sky in the years following the detection. 50 attempts to catch the signal in the act of existing 50 returns to the same quiet patch of the constellation. Sagittarius, the same frequency, the same careful attention. Each one came back empty. Not almost empty, not faintly suggestive. Empty in the way that makes you wonder whether you misread the first result. Except the first result was right there, circled in red, printed on paper, preserved and reviewed and confirmed to be exactly what it appeared to be. The Very Large Array in New Mexico joined the search as well. That instrument, a collection of large dish antennas spread across the desert floor, was among the most sensitive radio observatories in the world at the time. It turned its attention toward the coordinates that Big Ear had flagged, and it listened with the kind of precision that Big Ear, for all its dedication, could not match. It heard nothing. No repeat, no echo, no faint continuation of whatever had passed through the Ohio sky on that August night. And this is where the story becomes genuinely difficult to hold. Because repetition is not a minor detail in the search for extraterrestrial signals. It is close to the heart of the entire enterprise. A natural source that emits radio waves tends to keep emitting them. A pulsar pulses. A quasar radiates. The cosmic microwave background fills every direction with its ancient, even warmth, never pausing, never varying in the way the wow signal varied. Consistency is what natural sources do. And a deliberate beacon, if that is what someone or something were trying to send, would face a practical problem. The universe is vast, and the number of possible recipients is unknown. And the only way to be heard across that vastness is to transmit repeatedly, to keep the signal going long enough that someone, somewhere, happens to be listening at the right moment. The wow signal appeared to arrive at exactly the right moment, and then it never came back. That asymmetry is the thing that resists easy explanation. If it was natural, it should have been detectable again, either continuously or in some predictable pattern. If it was artificial and intentional, the logic of communication suggests it should have repeated, because a message sent only once to a galaxy full of possible listeners is barely a message at all, unless the beam was narrow, unless the transmission was moving, unless the geometry of that moment, the angle of the source, the rotation of the Earth, the precise alignment of the telescope's feed horn with whatever was out there, was a coincidence so specific that it could not be reconstructed simply by pointing the same instruments at the same coordinates. That possibility is not comfortable, but it is honest. A narrow beam transmission, sweeping through space the way a lighthouse beam sweeps across water, would pass a given point only briefly. From the telescope's perspective, it would look exactly like what the wow signal looked like: a smooth rise, a peak, a smooth fall, lasting no longer than the beam took to cross the instrument. And then it would be gone, continuing its arc through the galaxy, perhaps reaching other ears, perhaps reaching none. The sky does not explain itself. What the follow-up observations established, with quiet certainty, is that whatever produced the wow signal was not a persistent, stable source sitting in that region of Sagittarius and broadcasting continuously. It was something that happened once, in a window of 72 seconds, and did not happen again in any of the 50-plus attempts to find it. That is not a resolution. It is a sharper version of the question. Some signals, when they refuse to repeat, eventually find their explanation in something overlooked: a satellite whose orbit brought it briefly into view, a piece of interference that mimicked the shape of something real, a calibration artifact that fooled the instrument for a moment. These explanations are not satisfying, but they are often correct, and science has learned to prefer them over more dramatic alternatives until the evidence demands otherwise. The wow signal has resisted that process. Not because researchers have not tried. They have tried carefully, and at length, and with instruments far more capable than the one that made the original detection. But the ordinary explanations have not held. The extraordinary ones have not been confirmed, and the signal itself has not returned to settle the matter. Nearly 5 decades have passed since Jerry Amon drew that circle. The big ear is gone now, replaced by something that has no interest in the sky. The printout survives, the red ink still legible, the letters still spelling out their quiet sequence. The coordinates in Sagittarius are still there. Of course, the sky does not move in any way that matters on human timescales, and modern telescopes with sensitivities that would have seemed almost impossible in 1977 have looked at that region and found nothing to explain what happened. The absence of repetition does not prove the signal was extraordinary, but it does mean the question has never closed. It remains open the way certain questions remain open, not because we have failed to look, but because looking has not been enough. The universe is under no obligation to repeat itself for our benefit. It does not owe us a second transmission, a confirmation, a sign that the first one was real. It simply continues. And somewhere in the direction of Sagittarius, in a region dense with ancient stars, the radio sky is quiet tonight. The same quiet it has offered every night since 1977. Patient and unchanged, holding whatever it knows in the way that vast things hold things. Without urgency, without explanation, and without any particular concern for whether we are still listening. And yet the silence itself invites a question, not a loud one, not the kind that demands an answer, but a quiet one, the kind that settles at the edge of thought as you lie still. If the signal was real, and nothing has proven it was not, then what was it? There are a few possibilities, none of them certain, each of them worth sitting with for a moment. The first is perhaps the most elegant in its simplicity. The signal may have been a deliberate transmission, a narrow beam of radio energy, aimed with precision, sweeping slowly across the galaxy the way a lighthouse beam sweeps across dark water, not broadcasting in all directions at once, which would require enormous energy, but focused, concentrated, sent along a specific line through space. If something sent a beam like that, it would not linger. It would pass through the position of our small planet the way a searchlight passes through fog, briefly, completely, and without pausing to confirm it had been seen. 72 seconds, and then gone. Not because the transmission ended, but because the beam had moved on, continuing its slow arc through the galaxy, perhaps touching other worlds in other years, perhaps never touching ours again. There is something almost peaceful in that image, a signal not meant to overwhelm, not meant to flood every frequency at once, but to travel quietly along a single line, patient, unhurried, indifferent to whether anyone was positioned correctly to receive it. We were, perhaps, simply in the right place at the right moment. And then the moment passed. The second possibility is less poetic, but no less strange. It involves something called interstellar scintillation. The space between stars is not empty. It is threaded with vast, diffuse clouds of ionized gas, plasma, loosely spread across distances that take light years to cross. Radio waves passing through these clouds are bent and scattered, much the way starlight shimmers when it passes through layers of warm and cool air near the ground. The stars do not actually tremble, but the light does. Radio waves do the same thing. A source that is normally too faint to detect can, under the right conditions, be briefly focused by one of these clouds, amplified, the way a lens concentrates light, and for a short time it becomes bright enough to register on a telescope. Then the geometry shifts, the cloud moves, or the alignment changes by some small fraction, and the signal fades back below the threshold of detection, not because it stopped, but because the natural amplifier moved away. If scintillation was responsible for the wow signal, then the source itself may still be there, still transmitting, or still emitting in whatever way it does, quietly, persistently, at a level that our instruments cannot quite reach, waiting, in a sense, for another chance alignment that might never come, or might come again in 100 years. or 1,000, when different instruments are pointed at a different sky. That possibility carries its own kind of quiet weight. The idea that something is still out there, still producing that narrow frequency, still sending whatever it sends, but separated from us by distance and physics and the slow drift of gas clouds across the line of sight. Present, but unreachable. Audible once, by accident, and silent ever since, not by choice, but by geometry. It is not a comforting thought. Exactly. But it is not a frightening one either. It is simply the universe being what it is, vast, and indifferent to the convenience of our instruments. Then there is a third hypothesis, one that arrived much later. In 2016, nearly 4 decades after the signal was recorded, an astronomer named Antonio Paris proposed that the source of the WOW signal might have been something far more familiar than an alien transmission or a distant scintillating source. He suggested it might have been a comet. 2 comets, specifically one designated 266P Christensen and another known as P2008Y2. Paris argued that at the time of the detection, in August of 1977, these comets were in the vicinity of the signal's coordinates in Sagittarius. And comets, as they travel through the inner solar system, release gas, including hydrogen. The outer envelope of a comet, called the coma, can extend for enormous distances, and within that envelope, hydrogen atoms emit radiation. The frequency of that emission is close to 1420 megahertz, close to the hydrogen line. And so the proposal was that what Big Ear detected was not a distant artificial signal, but the natural radio emission of a comet passing through the telescope's field of view. It was a careful proposal, and it deserved careful consideration, and it received it. The response from other researchers was measured but skeptical. Several problems emerged on examination. Cometary hydrogen emission had been studied before, and it had never been observed at anything approaching the intensity the WOW signal displayed. The peak of that signal was roughly 30 times above the background noise level, a strong detection by any standard. Cometary emission, as far as anyone had measured it, did not produce signals of that character. There were also questions about the geometry. The proposed comets, when their positions were reconstructed more precisely, did not appear to have been exactly within the telescope's beam at the moment of detection. The alignment that the hypothesis required was not as clean as it first appeared. And there was the matter of bandwidth. The WOW signal was extraordinarily narrow, one of its most distinctive features, and one of the reasons it attracted attention in the first place. Natural radio sources, including comets, tend to emit across broader frequency ranges. A signal as narrow as the one Eamon circled does not fit easily into what we know about cometary emission. The comet hypothesis has not been accepted as a consensus explanation. It remains contested. Some researchers consider it worth continued investigation. Others find the objections substantial enough to set it aside, as it tends to do with genuinely difficult questions, has not reached a single verdict. And so the 3 hypotheses sit alongside each other. A sweeping narrow beam from something deliberate, a natural source briefly amplified by the physics of interstellar gas, or a comet, close and familiar, emitting at a frequency that happened to resemble something far more unusual. None of them fully satisfies. Each of them leaves something unexplained. The narrow bandwidth, the single horn detection, the smooth Gaussian rise and fall, the absence of any repeat. These features do not all fit neatly into any one explanation. They form a shape that no known template quite matches. That is, in the end, what makes the WOW signal what it is? Not certainty in any direction, but a persistent, quiet resistance to being explained away. It was detected once, on a summer night in 1977, by a telescope that no longer exists, reviewed days later by a volunteer with a red pen. and in the nearly 5 decades since, it has not returned. The hypotheses continue to be refined. New data is gathered, new instruments listen, and the signal itself remains what it has always been: a sequence of characters on a paper printout, a margin note in faded ink, and a question that the universe has so far declined to answer. Not with silence that feels like refusal, but with the kind of silence that simply continues. The way the sky continues, steady and deep and patient beyond any measure we have for patience. And yet the comet hypothesis did not settle quietly into the record. When Antonio Paris put forward his proposal in 2016, it was examined carefully, as any hypothesis about the WOW signal tends to be. The idea had a certain appeal. Comets release hydrogen gas as they warm near the sun, and hydrogen gas emits near the hydrogen line frequency. It offered a natural, local explanation for something that had resisted natural, local explanations for nearly 4 decades. But the closer researchers looked, the more the fit seemed to loosen. One of the first difficulties was intensity. Cometary hydrogen clouds had been observed before, and their radio emission had been measured. What had never been observed was a cometary hydrogen source producing emission anywhere near as strong as what the Big Ear recorded that August night. The signal Amon circled was roughly 30 times above the background noise level. That is not a faint whisper from a passing cloud of gas. It is a sharp, structured peak. And cometary emission, as far as the observational record shows, does not produce peaks like that. The second difficulty was position. Careful reconstruction of where the proposed comets, 266P Christensen and the object designated P2008Y2, actually were on the night of August 15, 1977, suggested they were not precisely within the narrow beam of the Big Ear telescope at the time the signal was recorded. The Big Ear's beam was not wide. It sampled a thin strip of sky, and the geometry of the proposed cometary positions did not align cleanly with that strip. Not impossibly far, perhaps, but not a clean match either. These are the kinds of details that matter in radio astronomy. A telescope beam is not a vague region of sky. It is a specific, calculable cone, and whether a source falls inside it or outside it is not a matter of interpretation, it is a matter of geometry. And then there was the question of the signal's character itself. Some researchers noted that the polarization properties and the bandwidth of the WOW signal were not consistent with what cometary hydrogen emission would be expected to produce. Cometary hydrogen tends to emit across a broader range of frequencies. The WOW signal was narrow, unusually, almost strikingly narrow, narrower than most natural astrophysical processes tend to produce. That narrowness had always been one of its most distinctive features, and it remained difficult to reconcile with the diffuse, spread-out emission that a hydrogen cloud around a comet would generate. None of this means the comet hypothesis is impossible. Science rarely deals in impossibilities. It deals in likelihoods, in consistency with evidence, in whether a proposed explanation accounts for all the features of what was observed or only some of them. And the comet hypothesis, as it stands, accounts for some, but not all. It remains contested. It has not been accepted as a consensus explanation among the researchers who have studied the signal most carefully. It sits alongside the other hypotheses, neither confirmed nor fully dismissed. That is an uncomfortable place for an explanation to sit. But it is where the WOW signal tends to leave things. There is one more category of explanation that has been examined over the years, and it deserves its own quiet consideration. The possibility that the signal came not from space at all, but from somewhere much closer, from the ground, or from the air. A satellite, perhaps, or an aircraft passing through the telescope's field of view. This possibility was not ignored. It was looked at seriously. the way any responsible investigation looks at the simplest available explanation before reaching for more distant ones. And for the most part, it was set aside. The reason has to do with the protection that was already in place long before the WOW signal was ever recorded. The frequency at which the signal appeared centered near 1420 megahertz. The hydrogen line is not an open channel. It is a protected band. The International Telecommunication Union, the body that coordinates radio frequency use across the world, designates the hydrogen line region as passive, receive only, no transmissions permitted. That designation exists precisely because the hydrogen line is scientifically valuable. Radio astronomers need to be able to listen at that frequency without interference from human-made sources, so the band is kept quiet by international agreement. Satellites in 1977 were not authorized to transmit anywhere near it. Aircraft were not transmitting there either. This does not make human-made interference a mathematical impossibility. Rules are not always followed. Undocumented transmissions are not unheard of in the history of radio, and some researchers have noted, carefully and without drama, that the possibility of an undocumented human-made source cannot be reduced entirely to zero. But it is a small possibility. The protected status of the band, the fact that the signal appeared in only one feed horn and not the other, which is inconsistent with how local interference typically behaves, and the smooth, point source profile of the signal's rise and fall all work against a terrestrial explanation. Local interference tends to be messy. It tends to appear in multiple channels, to lack the clean Gaussian shape that the WOW signal displayed, to behave like something nearby rather than something distant and fixed against the sky. The WOW signal did not behave like something nearby. It behaved like something very far away, moving slowly across the telescope's field of view the way a star moves, carried by the rotation of the Earth, drifting through the beam at exactly the rate a fixed celestial source would drift. That behavior is not easy to fake with a satellite or an aircraft. Those objects move differently. They have their own trajectories, their own velocities, their own signatures in the data. And so the terrestrial explanation, like the cometary one, was examined and found wanting. Not impossible, but insufficient. Not a clean fit for all the features that needed explaining. What remains, then, is a signal that has survived scrutiny from several directions. It is not that no one has tried to explain it. Many people have tried, with care and with rigor. It is that the explanations that have been offered each leave something on the table, something unaccounted for, some feature of the signal that the proposed cause does not quite reach, the narrow bandwidth that natural sources struggle to produce, the single horn detection that argues against local interference, the intensity that exceeds what cometary emission has ever been observed to generate, the smooth rise and fall that points to a fixed, distant source, the absence of any repeat in 50 follow-up observations across multiple telescopes over nearly 5 decades. Each of these features, taken alone, might be explained, but together, they form a combination that no single hypothesis has yet managed to account for completely. They sit together in the record, patient and unresolved. The way certain questions sit, not demanding an answer, but not releasing one either. The sky above Sagittarius is the same sky it has always been, dense with stars toward the galactic center, crossed by radio waves from 100 natural sources, listened to now by instruments far more sensitive than the flat ground plane reflector that first caught that brief, anomalous peak on a summer night in Ohio. And still, in all that listening, nothing quite like it has come again. There is one more layer worth sitting with before the silence settles completely. The frequency the WOW signal arrived on is not open territory. The hydrogen line, 1420.4005 MHz, is protected, not by custom or convention, but by international agreement. The International Telecommunication Union, the body that coordinates how humanity uses the radio spectrum, has designated that band as passive. Passive means receive only. No transmitter, anywhere on Earth, is permitted to broadcast in that range. It is reserved entirely for listening, for radio telescopes and the researchers who use them to study the quiet signals that arrive from space. That protection exists precisely because the hydrogen line is so scientifically valuable. Any human-made noise in that band would contaminate the very observations the band was set aside to enable. So when the WOW signal appeared at that frequency, one of the first and most obvious explanations that some terrestrial transmitter had leaked interference into the telescope ran immediately into that wall. The signal was sitting in a band where human transmitters are not supposed to exist. And yet, some researchers have never fully closed that door. The protection is real, and it is enforced. But enforcement is not the same as perfection. Undocumented transmissions, equipment malfunctions, signals from sources that were never cataloged, these remain, as a few researchers quietly note, a non-zero possibility. Not a likely one. Not a favored one. But science tends to be careful about the word impossible, and so the door stays open just a crack, not wide enough to walk through, but enough to let a little uncertainty remain. It is the kind of uncertainty that does not resolve itself through argument. It resolves, if it resolves at all, through evidence. And the evidence, in this case, has not arrived. So the signal sits where it has always sat, unexplained, unconfirmed, and unrepeated, in a protected band of sky that was designed, in a sense, for exactly this kind of listening. The instrument that did the listening is gone now. The Big Ear telescope, the flat ground plane reflector that stretched across the Ohio landscape, roughly the size of 3 football fields, patient and unhurried in its transit of the sky, was demolished in 1998. Not because it had failed, not because something better had been built in its place at that site. It was demolished to make way for a golf course expansion. The land it occupied was sold, and the telescope was taken down, and the place where one of the most discussed signals in the history of radio astronomy was recorded became, in time, a stretch of fairway. There is something quietly strange about that. Not tragic, exactly. Telescopes are instruments, and instruments are replaced. But the Big Ear was not replaced at that location. It was simply ended. And its ending carries a particular weight in the context of the WOW signal, because the original instrument that detected the signal can never now be used to search for a repeat. If the signal returned tomorrow, if something in the direction of Sagittarius began transmitting again at 1420 MHz with that same narrow bandwidth and that same smooth Gaussian rise and fall, the Big Ear would not be there to hear it. The specific geometry of that telescope, the particular way its 2 feed horns sampled the sky, the exact strip of sky it was designed to monitor, all of that is gone. What remains is the printout. The paper record with Jerry Amon's red circle and his handwritten word in the margin. Preserved, displayed, studied, but unable to listen. The sky above that stretch of Ohio is the same sky it always was. The coordinates in Sagittarius are still there. The hydrogen line is still protected, but the instrument that first noticed something unusual in that direction has been absent for more than 25 years now. And the sky has not repeated itself in all that time. What has changed is the quality of the listening. The telescopes that now scan the radio sky are instruments the builders of Big Ear could only have imagined. The Allen Telescope Array in Northern California, a field of individual dishes working together, was designed specifically with SETI observations in mind. Among other purposes, it can monitor multiple frequencies simultaneously and survey large areas of sky in ways that a transit telescope like Big Ear could not. And then there is FAST, the 500-meter aperture spherical telescope, built into a natural depression in the landscape of Guizhou province in China, completed in 2016. 500 meters across. A single dish, half a kilometer in diameter, the largest of its kind ever constructed. Its collecting area dwarfs anything that came before it. The sensitivity it brings to radio astronomy, the faintness of the signals it can detect, the precision with which it can resolve them, represents a step change in what is possible. Big Ear, for all its years of patient listening, was a relatively modest instrument by the standards of what now exists. The signals it could detect were the louder ones. The signals that FAST can reach are far quieter, far more distant, far more subtle. If the WOW signal source is still transmitting at the same power, in the same direction, FAST would have a far better chance of finding it than Big Ear ever did. And FAST has conducted its own observations in the context of the search for signals of possible non-natural origin. It has surveyed regions of sky, monitored frequencies of interest, brought its enormous collecting area to bear on the question that has occupied radio astronomers since the field began. And it has not reported anything resembling the WOW detection. Neither has the Allen Telescope Array. Neither has the Very Large Array, which searched the WOW coordinates in the years after 1977. Neither has the Breakthrough Listen initiative launched in 2015, the most comprehensive program of its kind ever funded, using large existing telescopes to survey millions of star systems across a wide range of frequencies. Millions of star systems. And in all of that listening, across all of those frequencies, with instruments of sensitivity that would have seemed extraordinary to the researchers who built Big Ear, nothing quite like it has come through. That silence is its own kind of data. It does not prove the WOW signal was natural. It does not prove it was artificial. It simply extends the record of non-detection, year by year, telescope by telescope, into a silence that grows longer and more complete with each passing survey. The universe, as far as we can tell, is very old, roughly 13.8 billion years, and very large. Hundreds of billions of galaxies, each containing hundreds of billions of stars, many of them orbited by planets. Some of those planets sitting in the range of temperatures where liquid water can exist. The conditions for life, as we understand them, appear to be neither rare nor recent. And yet the radio sky, for all its richness, for all its pulsars and magnetars, and the faint background hum of the Big Bang itself still washing over us, has not offered a second moment like the one recorded on that paper printout in the summer of 1977. One signal, 72 seconds. A single feed horn. A red circle drawn in ballpoint pen by a volunteer researcher who came in to review the data days after it was collected. And then, nothing. The instruments have grown more powerful. The surveys have grown more thorough. The silence has grown, in its own quiet way, more profound. And still, the search continues. In the Guizhou province of southern China, nestled inside a natural karst depression in the hills, there is a structure so large it cannot be taken in from a single vantage point. A dish 500 meters across, built into the landscape itself, as though the Earth had been gently pressed inward to receive something. It is called FAST, the 500-meter aperture spherical telescope, and it is the largest single-aperture radio telescope ever constructed. It was completed in 2016. Its surface is made of roughly 4,500 triangular aluminum panels, each one adjustable, the whole structure capable of focusing on different regions of sky by reshaping itself in real time. The dish is so wide that if you stood at its center and looked toward the rim, the edge would be nearly as far away as 5 city blocks. It collects radio waves the way a vast, still lake collects rain, quietly, patiently, across an enormous area. FAST has turned its attention to the sky coordinates associated with the WOW signal. It has listened, with sensitivity far beyond anything available in 1977, and it has heard nothing resembling what Jerry Amon circled in red on that summer printout. That is not a failure. It is simply the record extended once more. Around the same time, FAST was taking shape in those Chinese hills. A different kind of effort was being organized on the other side of the world. In 2015, a program called Breakthrough Listen was announced, privately funded, ambitious in scope, and designed to be the most systematic search for extraterrestrial signals ever attempted in terms of dedicated observing time. Breakthrough Listen does not operate its own telescope. Instead, it purchases time on existing large instruments, among them some of the most capable radio observatories on Earth, and uses that time to survey the sky with a thoroughness that earlier SETI programs could not approach. Millions of star systems have now been examined under its watch. The data collected is made publicly available, processed by algorithms searching for the kinds of structured, narrowband signals that would be difficult to explain as natural phenomena. No confirmed detection has been reported. Millions of stars, each one a sun, many of them older than our own, many of them circled by worlds, and across all of that surveyed sky, no second. WOW signal, no structured pulse, no narrow frequency spike rising cleanly above the noise. The silence, at this scale, begins to ask its own question. It is a question that the physicist Enrico Fermi is said to have raised informally over lunch sometime in the early 1950s. The details of the conversation are uncertain, passed down through memory rather than record. But the question itself has become one of the most quietly unsettling in all of science. If the universe is as old as it appears to be, nearly 14 billion years, and if stars have been forming and dying and forming again across that entire span, and if even a small fraction of the planets circling those stars developed life, and even a smaller fraction of that life developed intelligence, and even a smaller fraction of that intelligence developed the capacity to communicate across interstellar distances, then where is everyone? That is the Fermi paradox. Stated simply, the universe seems old enough, and large enough, and full enough of the right conditions, that the absence of any confirmed contact is itself something that requires an explanation. There is no shortage of proposed answers. They range from the sobering to the strange, and none of them has been ruled out. One possibility is that the conditions for life, while not impossible, are rarer than they appear. The Earth is not merely a planet with liquid water. It is a planet with a large, stabilizing moon that moderates the tilt of its axis. It orbits a calm, middle-aged star that does not frequently flare. It sits in a relatively quiet region of the galaxy, away from the dense and violent center. It has a giant outer planet, Jupiter, whose gravity deflects many of the large impactors that might otherwise sterilize the inner solar system. Each of these factors, taken alone, may be common. Taken together, they may be rare. And if complex life requires all of them simultaneously, the galaxy may be far emptier than the raw numbers suggest. Another possibility is that civilizations arise, but do not persist. The same intelligence that allows a species to build radio telescopes also allows it to develop technologies capable of causing its own extinction, whether through conflict or environmental collapse, or the unintended consequences of powerful tools, the window during which a civilization is both capable of communication and still present may be very narrow. Narrow enough that two civilizations might never overlap in time, even if they exist in the same region of the galaxy. This idea is sometimes framed as the Great Filter, the notion that somewhere along the path from simple chemistry to spacefaring civilization, there is a step so difficult that almost nothing gets through. The unsettling question is whether that filter lies behind us or ahead. If it lies behind, if the hard step was the origin of life, or the emergence of complex cells, or the development of multicellular organisms, then we may be among the rare ones who made it through, and the silence around us is the silence of a galaxy that mostly did not. If the filter lies ahead, the silence takes on a different quality entirely. There are gentler possibilities. Perhaps civilizations are common, but communication across interstellar distances is simply not something they attempt. The distances are vast. A signal sent from a star 40 light-years away takes 40 years to arrive, and any reply takes 40 more. A conversation conducted across such distances would span human lifetimes between exchanges. Perhaps the practical barriers to interstellar communication are high enough that most civilizations, however advanced, simply do not bother. Or perhaps they communicate in ways we have not yet thought to look for. Radio waves are one small slice of the electromagnetic spectrum, and the electromagnetic spectrum is one small part of the physics available to the universe. We have been listening in one language, in one frequency range, for a few decades, against the age of the galaxy. That is a very short time, and a very narrow search. There is also the possibility that the sky is not silent at all, that it is full of signals we are not yet equipped to recognize. A message sent by a civilization millions of years more advanced than our own might not resemble anything we would identify as a message. It might look, to our instruments, like noise, or like a natural phenomenon we have not yet correctly categorized. The wow signal, in this light, is interesting precisely because it did not look like noise. It looked structured. It rose and fell in the smooth curve expected of a distant point source. It appeared at a frequency that physicists had specifically identified as meaningful. It lasted the right amount of time. It did everything a signal should do, except return. And that absence, that single, unrepeated moment, is where the question lives. Not in certainty, not in proof, but in the gap between what the universe seems capable of producing and what we have, so far, been able to confirm. The instruments are more sensitive now than they have ever been. The surveys are more thorough. The sky is being listened to with more care and more patience than at any previous point in the history of the species that built the telescopes. And the question Fermi asked over lunch, in whatever words he actually used, remains open. Quiet, unresolved, patient as the sky itself. There is another possibility that sits quietly alongside all the others, one that does not require catastrophe, or rarity, or the slow extinction of civilizations before they can reach across the void. It simply suggests that the others are there, and that they are not speaking. Not because they cannot, but because they have chosen not to, or because the way they speak is nothing like the way we listen. We have been scanning the sky for structured radio signals for roughly 6 decades now. We have looked for patterns in narrow frequency bands, for pulses, for repeating sequences. All of that searching has been shaped, quietly but completely, by the assumption that another civilization would communicate the way we do, or at least the way we imagine we would if we were trying to be heard. But that assumption may be the limitation. A civilization that has existed for 1 million years, or 10 million, might have moved so far beyond radio transmission that our surveys are the equivalent of listening for drum beats in a city full of fiber optic cables. The signal would not be absent. It would simply be in a form we have not yet thought to look for. And so the silence, if it is silence, may be a silence of translation rather than a silence of absence. This is not a comforting thought, exactly, but it is a patient one. It suggests the search is not over, only that it may need to change shape. Against all of that uncertainty, one moment from the summer of 1977 continues to hold its place. Not because it answered anything, but because it has resisted, for nearly 5 decades now, every attempt to explain it away. The WOW signal is sometimes described as the single most compelling candidate signal in the entire history of the search for extraterrestrial intelligence. That is a careful description, and it is worth sitting with. Not the most dramatic, not the most conclusive, the most compelling. What makes it compelling is not what it proved, it is what it failed to disprove. Every natural explanation that has been proposed has come with problems. Every terrestrial explanation has run into the protected status of the frequency, the single horn detection, the shape of the signal itself. The Comet hypothesis arrived with some initial interest and then quietly accumulated objections. The scintillation hypothesis is plausible in outline, but difficult to confirm in detail. And the simplest explanation of all, that it was a mistake, a glitch, an artifact of the equipment, has never found a foothold because the data is clean and the profile is exactly what it should be. So the signal sits unexplained, not proven to be anything in particular, but not dismissed either, held in a kind of careful suspension, the way a question is held when the people asking it are honest enough to admit they do not yet have the answer. Nearly 50 years have passed since that August night. The field of radio astronomy has grown enormously. The instruments are more sensitive, the surveys more systematic, the computational tools more powerful, and still, nothing quite like it has appeared again. That absence of repetition is part of what keeps the question open. A confirmed extraterrestrial signal would almost certainly repeat, or at least be recoverable. A one-time event is harder to classify. It could be a beacon that swept past and moved on. It could be a natural phenomenon that has not yet been correctly identified. It could be something in between, something that does not fit neatly into either category. The honest answer is that we do not know, and the honest answer is also that not knowing, after this long, is itself a kind of data. There is something worth knowing about the name. The WOW signal was never given a formal scientific designation. It does not have a catalog number or an official identifier in the way that most astronomical objects do. Its name comes entirely from a single word written in red ballpoint pen by a volunteer researcher on a paper printout. Sometime in the days after the detection, Jerry Amon was not a senior scientist at the time. He was reviewing data as part of his work with the Big Ear survey, going through the printout the way he had gone through many printouts before. And then he saw the sequence, 6 characters rising and falling in a smooth arc, centered on the hydrogen line, lasting exactly as long as a point source should last as it drifts through a telescope beam. He circled it. And in the margin, in the same red pen, he wrote one word. Wow. That annotation became the signal's name. Not through any formal process, not through a committee or a publication, simply because the word was there, on the paper, and it captured something that no technical description quite managed to capture: the quality of the moment when a pattern appears in the noise that should not be there, the quiet shock of it. Amon himself has been careful, over the years, not to overclaim. He has said, in various interviews and writings, that he does not believe the signal was necessarily extraterrestrial. only that it was unexplained. That distinction matters to him, and it is the right distinction to make. An unexplained signal is not the same as an alien signal. It is simply a signal for which no satisfying explanation has yet been found. That is a more modest claim, and it is also, in its modesty, a more durable one. It does not require the signal to be anything other than what it was, a brief, anomalous, structured radio event that appeared once and did not return. Everything else is interpretation. The original printout still exists. A long sheet of paper covered in columns of alphanumeric characters, the kind of output that was ordinary for radio telescope surveys of that era. And somewhere in those columns, circled in red, the sequence that changed the way the event would be remembered. 6 characters, 1 word in the margin. It has been displayed publicly, in exhibitions and archives, and there is something quietly affecting about seeing it. Not because it proves anything, but because it is so ordinary in its form and so extraordinary in what it represents. A piece of paper, a red pen, a word written by a person who was paying attention. The printout is a record of a moment when the universe, or something in it, or something we have not yet correctly understood, produced a signal that a human being found worth circling. And that circle, drawn in a moment of quiet surprise, has held its shape for nearly half a century. The sky has been listened to many times since then, with larger instruments, wider surveys, more careful analysis. The coordinates in Sagittarius have been revisited dozens of times. Nothing comparable has emerged. And so the signal remains what it has always been: a single moment, unrepeated, unexplained, held in the margin of a printout, in the handwriting of a person who was simply doing his work on an ordinary day and found something that did not fit. The universe is very old. It has had a great deal of time to produce things we do not yet understand. And on one night in August, in the summer of 1977, something passed through the beam of a flat-ground telescope in Ohio, rose to 30 times the background noise, and fell away again. It has not come back. But the listening continues. Quiet, patient, careful. The way all good listening does. Radio astronomy itself is only about 90 years old. Carl Jansky was an engineer working for a telephone company in 1932, trying to track down sources of static that interfered with transatlantic radio calls. He built a rotating antenna in a field in New Jersey, and he found something unexpected: a persistent hiss that rose and fell on a regular cycle. He traced it, carefully, to the center of the Milky Way, the heart of our own galaxy, broadcasting quietly in radio waves that no human instrument had ever caught before. It was not a dramatic discovery in the way that word is usually used. Jansky published his findings, and the world largely moved on. But the door had opened. Since then, we have learned that the universe is extraordinarily loud in radio frequencies, if you have the instruments to hear it. Supernovae, the deaths of massive stars, send out radio waves as their expanding shells of gas collide with the material around them. Pulsars, the dense spinning remnants left behind after those deaths, sweep beams of radio energy across the sky with the regularity of a lighthouse. Magnetars, which are pulsars with magnetic fields so intense they warp the fabric of space around them, occasionally release bursts of radio energy so powerful they can be detected across billions of light years. And beneath all of it, behind all of it, in every direction at once, there is the cosmic microwave background. This is the faintest and oldest radio signal in existence. It is the afterglow of the Big Bang itself. In the first moments of the universe, everything was unimaginably hot and dense, and the entire cosmos glowed. As the universe expanded and cooled over hundreds of thousands of years, that glow stretched with it, shifting from visible light down through infrared, down into microwave frequencies. And it is still there, everywhere. A whisper from the beginning of time, arriving from all directions simultaneously, detectable by any radio telescope pointed anywhere at all. Against that background, against the pulsars and the magnetars and the ancient hiss of creation, a narrow signal stands out the way a single voice carries across a quiet room. Not because the room is silent, the room is never silent, but because the voice has a shape that the noise does not. That is what made the wow signal worth circling. Not just its strength, though it was strong. Not just its frequency, though the frequency was suggestive, but its shape. The way it rose and fell smoothly, the way it occupied a narrow band, the way it appeared in one place and nowhere else. It had the character of something deliberate, or at least of something very different from the background it arrived against. And yet the universe is old enough and large enough that the absence of more signals like it is its own kind of question. The Milky Way is roughly 13 billion years old. It contains somewhere between 200 and 400 billion stars. Many of those stars are far older than our sun. If life arose elsewhere even a billion years before it arose here, whatever that life became would have had a billion years more than we have had. A billion years is a span of time almost impossible to hold in the mind. In a billion years, the continents of Earth will have rearranged themselves entirely. In a billion years, our sun will have noticeably brightened. A civilization with a billion-year head start could, in principle, have done things we have no framework to imagine. And yet the sky is quiet. This is sometimes called the Fermi paradox, after the physicist Enrico Fermi, who is said to have asked the question simply and directly over lunch one afternoon, "Where is everybody?" It is not really a paradox in the formal sense, it is more of a tension between the apparent conditions for life being widespread and the apparent absence of any confirmed sign of it. There are many ways to hold that tension. One possibility is that life, while perhaps not unique to Earth, is genuinely rare. That the sequence of events required to produce complex, communicating beings is so improbable that it has happened only a handful of times in the observable universe, or perhaps only once. This is sometimes called the rare Earth hypothesis. It does not require that the universe be hostile to life, only that the precise conditions for it are difficult to assemble. Another possibility is that life arises often, but intelligence does not, or that intelligence arises, but technology does not, or that technology arises, but the window during which a civilization is both capable of communication and interested in attempting it is very short. Perhaps civilizations tend to destroy themselves or transform themselves into something that no longer broadcasts. Perhaps the silence is not emptiness, but aftermath. There is a related idea sometimes called the Great Filter, the notion that somewhere along the path from simple chemistry to spacefaring civilization, there is a step so difficult that almost nothing gets through it. The unsettling version of this idea is that the filter might still lie ahead of us, rather than behind. Or perhaps the civilizations are there, and simply quiet, choosing not to broadcast, or broadcasting in ways we have not thought to look for, or communicating on timescales so long that a single exchange takes centuries, and we have only been listening for decades. Or perhaps the universe has more room in it than we can currently perceive. There are theories in physics, serious mathematical frameworks, not speculation, that propose the universe contains more dimensions than the three we move through. String theory, in some of its forms, requires as many as 10 or 11 dimensions to remain internally consistent. These extra dimensions are not imagined as vast open spaces, They are thought to be curled up, compactified, folded into structures so small that they exist below the scale of anything we can currently measure, present everywhere, but invisible to every instrument we have built. In some versions of these theories, our entire universe is a kind of membrane, a brain, floating in a higher dimensional space. Other brains might exist nearby in that higher dimensional space, separated from us not by distance in any direction we can point, but by a dimension we cannot access. Parallel universes, in a sense, though the word parallel does not quite capture the geometry. If such structures exist, they might explain things that are otherwise difficult to account for. Why gravity is so much weaker than the other fundamental forces. For instance, one answer is that gravity leaks, that it propagates not just through our three dimensions, but through the higher dimensional space as well, spreading out and diluting in ways the other forces do not. It would arrive at us already weakened by a journey we cannot trace. These ideas are not confirmed. They may never be directly confirmed, given how small the proposed extra dimensions are. But there are experiments that look for subtle deviations in how gravity behaves at very short distances, searching for the faint signature of something beyond the three dimensions we know. So far, nothing has been found, but the search continues, in the same spirit as all the other searches. Careful, patient, aimed at something that may or may not be there. The WOW signal sits inside all of this, inside the long history of listening that began with Jansky's rotating antenna in a New Jersey field, inside the vast natural radio landscape of supernovae and pulsars and the ancient background glow, inside the unanswered question of why a universe this old and this large has not made itself more clearly known to us. Whether it was a voice or an echo, or a coincidence of nature shaped by processes we have not yet correctly understood, it has not spoken again. And the sky, as always, keeps its own time. Not our time. Not the time of a single night, or a single lifetime, or even a single civilization. The sky measures in billions of years, in the slow drift of stars, and signals that may travel for 100,000 years before arriving at an instrument small enough to fit in a field in Ohio. We have been listening, in any serious way, for less than a century. That is a very short time to expect an answer. And so, the listening continues, as it should, quietly, without urgency, the way you listen when you are not sure what you are waiting for, but you are certain that silence is not the same as nothing. And yet the silence itself is a kind of data. Scientists have a name for the unease it produces, the Fermi paradox, named for the physicist Enrico Fermi, who reportedly asked the question over lunch one afternoon in 1950, simply and plainly, where is everybody? It is a reasonable thing to wonder. The Milky Way is roughly 13 billion years old. It contains somewhere between 200 billion and 400 billion stars. A significant fraction of those stars are orbited by planets. A significant fraction of those planets sit at distances where liquid water could exist on their surfaces. The numbers, even when treated conservatively, suggest that the conditions for life have existed in this galaxy for a very long time, long before our sun ignited, long before the Earth had cooled enough to hold an ocean. And yet, no confirmed signal, no artifact, no pattern in the sky that requires intelligence to explain. Only, perhaps, a 72-second sequence of rising and falling intensity from the direction of Sagittarius, circled in red ink by a volunteer on a Tuesday. The silence is not proof of absence. That distinction matters. But it is still a silence that asks to be understood. One class of answers begins with rarity. Perhaps the emergence of complex life is not inevitable. Perhaps it requires a very specific arrangement of circumstances that almost never align. A star of the right age and stability, a planet of the right size, in the right orbit, with the right chemical inventory, a large moon to stabilize the planet's axial tilt, a giant outer planet to deflect incoming debris. Each condition, on its own, may be common, but all of them together, in the right sequence, at the right time. Perhaps that combination is extraordinarily rare. This is sometimes called the rare Earth hypothesis. The idea that simple microbial life might be widespread, but that the path from microbe to radio telescope is so narrow and so fragile that it has been walked only once, or nearly once, in the observable universe. If that is true, the silence makes sense. There is no one to answer because there is almost no one there. Another class of answers is darker. Perhaps life does arise with some regularity. Perhaps intelligence follows. But perhaps something happens, something that cuts civilization short before they can make themselves known across interstellar distances. This is the idea of the Great Filter, a barrier, somewhere along the path from chemistry to cosmos, spanning civilization, that almost nothing survives. The unsettling question is where that filter sits. If it lies behind us, if the hard step was the origin of life, or the emergence of the cell nucleus, or the leap to multicellular organisms, then we may have already passed through it. We may be among the rare ones who made it. That would be a quiet kind of relief. But if the filter lies ahead, if civilizations routinely reach a point of technological capability and then, through some combination of their own making, do not continue, then the silence around us is not a sign of our rarity. It is a sign of what may be waiting. No one knows which of these is closer to the truth. The honest answer is that we do not yet have enough information to say. There are gentler possibilities. Perhaps civilizations are out there, and they are simply not broadcasting in ways we would recognize. We have been listening primarily at radio frequencies, and only for a few decades. That is a narrow slice of the electromagnetic spectrum in an almost imperceptibly short window of time. A civilization that communicates by tightly focused laser pulses, or by methods we have not yet conceived, would be invisible to our current instruments, not because they are hiding, but because we are not yet equipped to hear them. Or perhaps they are listening too, waiting as we are waiting. Each civilization assuming that the burden of first contact falls on someone else. A galaxy full of quiet ears and no one willing to speak first. There is also the possibility that the universe contains something stranger than any of these answers. Physics, in its current form, does not fully describe reality. The two great frameworks of the 20th century, general relativity, which governs the very large, and quantum mechanics, which governs the very small, are each extraordinarily accurate within their domains. But they do not fit together cleanly. At the boundary between them, the mathematics breaks down, and that incompleteness suggests that our picture of the universe is not yet finished. One direction that theoretical physics has explored in trying to reconcile those frameworks is the possibility of additional dimensions. Not additional dimensions in a metaphorical sense, additional spatial dimensions, directions of extension that exist alongside the three we move through, length, width, depth, but that are somehow inaccessible to ordinary experience. This idea appears in string theory, which proposes that the fundamental constituents of matter are not point-like particles, but tiny vibrating filaments of energy. For the mathematics of string theory to remain consistent, it requires not 3 spatial dimensions, but 10. Or, in some versions, 11. The extra dimensions are thought to be compactified, curled in on themselves at scales so small that no current instrument could directly resolve them. roughly 100 billion times smaller than a proton. At that scale, the extra dimensions would be present everywhere, woven into the fabric of space itself, and yet entirely invisible to anything as large as an atom, let alone a human being. There is a related framework called brain cosmology. In this picture, the three-dimensional universe we inhabit is a kind of surface, a membrane, embedded within a higher dimensional space. Other membranes might exist nearby in that higher dimensional space, parallel to ours, separated not by any distance we could travel, but by an extent in a direction we cannot point to. Gravity, in some of these models, is the one force that leaks between membranes. It is the weakest of the fundamental forces by an enormous margin, far weaker than electromagnetism or the nuclear forces. And one proposed explanation for that weakness is that gravity is diluted across extra dimensions that the other forces cannot enter. If that is true, it would be a kind of hidden architecture underlying everything we observe. The universe we see would be a thin slice of something larger, and the thinness of that slice would explain why gravity feels so faint. These are not established facts. They are theoretical frameworks, some more mathematically developed than others, none yet confirmed by direct observation. But they are taken seriously by physicists not because they are exotic, but because they address real problems in the mathematics of the universe. There are ways they might leave traces. At very high energies, particles colliding in accelerators might briefly shed momentum into extra dimensions, producing a signature of missing energy that detectors could register. Gravitational wave observatories might, in principle, detect subtle deviations from the predictions of general relativity that would hint at additional structure in spacetime. The geometry of the early universe, imprinted on the cosmic microwave background, might carry faint statistical patterns that higher dimensional models predict. None of these signatures have been confirmed, but the searches are ongoing, and the instruments are becoming more precise with each passing year. It is a quiet kind of searching, the same quality of attention that points a radio telescope at a patch of sky and waits, the same willingness to sit with an open question and not force it toward a premature answer. The universe does not owe us clarity on any particular schedule. It has been here for nearly 14 billion years. It will continue long after every instrument we have ever built has gone dark. The questions we are asking now, about dimensions, about silence, about the faint possibility of other minds in the dark, are very new questions, asked by a very young species on a very ordinary planet, orbiting a very ordinary star. And there is something restful in that, if you let it be. There is a night in August 1977 that radio astronomy has never quite moved past. It was the 15th of the month, just after 11 in the evening, Eastern Time. A telescope in Ohio was doing what it always did, waiting. The big ear, as it was called, did not move. It could not steer toward anything. It simply lay flat against the ground, roughly the size of 3 football fields, and let the rotation of the Earth carry the sky slowly overhead, one strip of sky at a time, patient as a field. It had 2 feed horns. Each one sampled a slightly different slice of the heavens, separated by about 2 minutes of time. On that August night, something passed through the first horn, and not the second. The signal lasted no longer than 72 seconds from the telescope's perspective. It was not heard by anyone in real time. It was recorded on paper, in columns of alphanumeric characters, each letter or digit representing a level of signal intensity, and then it was set aside. Days passed. A volunteer researcher named Jerry Amon sat down with the printout. He was not a staff astronomer. He was someone who cared enough to give his time to the work. He moved through the columns the way you move through any long document, methodically, without expectation. And then he stopped. The sequence read 6 E Q U J 5, a rising intensity, then a peak, then a fall, smooth and symmetrical. The peak character, the letter U, corresponded to a signal roughly 30 times stronger than the background noise. Eamon reached for a red ballpoint pen. He drew a circle around the sequence, and in the margin, he wrote one word: wow. That handwritten annotation is the signal's only name. It was never given a formal scientific designation. It is still called simply the wow signal, after the quiet surprise of one person, alone with a printout, in the ordinary middle of a day. What made the signal so unusual was not just its strength. It was centered very close to 1420.405 MHz, the natural emission frequency of neutral hydrogen. Hydrogen is the most abundant element in the universe. Its emission frequency had been proposed since 1959 as a kind of cosmic common ground, a frequency that any civilization, anywhere, might recognize as a landmark. Physicists Philip Morrison and Giuseppe Cocconi had suggested it that year. If you wanted to send a message across interstellar space, they reasoned, you might choose the one frequency the entire universe already knows. The signal's bandwidth was extremely narrow, narrower than almost any natural astrophysical source. Pulsars and quasars and the great churning engines of the galaxy tend to emit across broad ranges of frequency, not in a single, precise, almost surgical spike. The shape of the signal, the way it rose and fell, matched exactly what you would expect from a fixed-point source drifting slowly through a telescope beam. That smooth curve, that Gaussian profile, is a signature. It separates a distant, stable source from the noise of local interference. And local interference, almost by definition, would have appeared in both feed horns at once. This did not. The signal seemed to come from the direction of Sagittarius, roughly toward the dense inner regions of the Milky Way, a part of the sky crowded with stars. No known natural object in that region has since been identified as a plausible source. Researchers went back again and again. More than 50 follow-up observations were made in the years after 1977. The Very Large Array in New Mexico searched the same coordinates. Nothing resembling the original signal was ever found. That silence is its own kind of puzzle. A genuine beacon, most researchers would expect, should repeat. It should be there when you look again. The wow signal was not. One possibility is that it was a narrow beam, deliberately aimed, that swept past the Earth only once and continued on its way into the dark. Another possibility involves something called interstellar scintillation, the way radio signals can be briefly amplified by clouds of ionized gas drifting between the stars, the way a lens focuses light. A normally faint source might flare into visibility for a minute or two, then fade back below the threshold of detection. If that is what happened, the source might still be transmitting quietly, just beyond what our instruments can reach. In 2016, a hypothesis emerged involving comets. 2 comets were proposed to have been near the signal coordinates at the time, their hydrogen gas potentially producing emission near the hydrogen line. The idea was examined carefully. Critics noted that cometary hydrogen had never been observed at anything close to the intensity the wow signal displayed. Further analysis suggested the geometry did not quite align. The hypothesis remains contested. It has not settled into consensus. The frequency itself offers some protection against a simpler explanation. The hydrogen line band is designated passive by international agreement. Receive only, no transmissions permitted. In 1977, satellites were not allowed to broadcast near that frequency. The protected status of 1420 MHz exists precisely because it is so scientifically valuable. Some researchers still allow a small possibility of undocumented human-made interference, but it is considered unlikely. The telescope that recorded all of this is gone now. The Big Ear was demolished in 1998. A golf course needed the land. The instrument that caught the only signal of its kind in the history of the search was taken apart, and the original question it raised was left open, without the means to pursue it in the same way again. Modern telescopes are far more sensitive. China's FAST telescope, 500 meters across, is the largest single-aperture radio telescope ever built. The Breakthrough Listen initiative has surveyed millions of star systems. The Allen Telescope Array watches the sky with patient, steady attention. None of them have reported anything resembling what Big Ear recorded on that August night. Jerry Amon himself has said he does not believe the signal was necessarily extraterrestrial, only that it was unexplained. That is a careful and honest position. The signal's candidacy rests not on certainty, but on the absence of a satisfying natural explanation after nearly 5 decades of looking. The original printout still exists. Amon's red circle still surrounds those 7 characters. His handwriting still sits in the margin, a small, human mark on a piece of paper that may or may not record the only moment we have ever brushed against another mind in the universe, or may record nothing more than a coincidence of physics that we have not yet fully understood. Both possibilities are held open. Radio astronomy itself began in 1932, when Carl Jansky detected radio waves from the center of the Milky Way. In less than a century, we have gone from that first accidental detection to instruments that can hear the faint afterglow of the Big Bang itself, the cosmic microwave background, a whisper of radiation that fills every direction of the sky, left over from the universe's earliest moments. Against that constant, ancient hum, a narrow signal, strong and structured, stands out the way a single voice carries across a very quiet room. Whether the wow signal was a voice, or an echo, or something the universe made without intention, it has not come again. The sky above Sagittarius looks the same as it always has, full of stars burning slowly in the dark, indifferent to the question we are holding. Somewhere in that direction, roughly 25,000 light years toward the galactic center, whatever produced that signal, if anything did, has continued on its own path through time. Unaware, perhaps, that something here was listening. And the night continues, as it always does, quietly.